Please tell me if you are. And I need to double check as well. Sorry for the delay, but we've been preparing some materials for you guys to make sure that this call is efficient and useful. Okay. Just checking if you're live myself. Okay, let's go live and let's see. Okay, I'm still checking. Okay, good. Okay, good morning and thank you. Okay, cool. To say that we are swamped is not to say anything. We are completely swamped on multiple fronts, and that's a good thing. It means that the project is moving forward. Now, I cannot say the same thing about my computer, which is extremely slow. So, I would like to start with the issues that lots of you guys experience on this side of validator set. So, somebody in Wales, I think, well, the Wales, therefore you guys, right? Prepared a whole number of issues, and thank you so much. That's exactly what we need. This is very, very helpful. We'll be explaining these issues or attacking these issues one by one. So that's very good. And let's start the educational process. So I would like to do the Vita to some extent as well, but the most pending issue is like what happens to the bridge, like, what really happened. So let's go step by step. We'll be trying to accommodate these issues. They're not out of ordinary, and to be honest, we did expect them ourselves in previous conversations internally. They took place, and there are some bugs on our side, and there are some kind of issues due to the centralization of the validator set that kind of the team and myself, we absolutely have been discussing this for a long, long time. So I've been personally warned, at least. All right. So first things first, right? So what is slashing, right? So let's go for slashing because that's the elephant in the room. I need to finish the Vita Money articles to some extent, right? We also need to finish the Ghost Chain and Ghost DAO articles. So the reason why they are behind, we behind on them is because so many things are happening outside outside of just writing it out. Like if there was if somebody's a writer, please ping me. That would be helpful. Technical writer specifically. But what I'm going to be presenting today as far as slashing, like I do not want to turn this into bits and pieces, like that you guys have to be fishing for information here and there just to just for for the team to be kind enough to drop those gems of the code base. That's not that's not how it should be done. We just swamped, guys, like absolutely swamped. We just don't have time for this, and we apologize that some of that information is not presented. So the good rule of thumb going forward, Scorpion, good morning. The good rule of thumb going forward is a number of Ghost DAO mechanics is inherited by Olympus DAO. So if something is not described, well, definitely lots of things for Ghost DAO not described, please refer to Olympus. Now you'll be of course surprised that Olympus does not have that much documentation either. Some of the documentation is wrong. And of course, as we have been discussing, we're changing the formula. We're changing the approach for native coin backend. That changes a lot of things. I wanted to present that today, but unfortunately I won't because there are more pending issues such as slashing. So we'll do that. And next time, hopefully, we'll be presenting the ETC backing scenario. Now, as far as Ghost chain specifics, what you should be referring to is Polkadot, right? So that's the inspiration. Now, again, both of them are not forked, but kind of the Ghost is inspired by Olympus on the side of Ghost DAO, and Ghost is inspired by Polkadot on the side of Ghost Chain. So some of those internal mechanisms of Polkadot will be very relevant for the Ghost as well. For example, finality, block proposition by validators, some type of sharding where you have 1,000 validators and a group of these validators is selected, right, to kind of suggest the block with then further finality approved by all validators. And the slashing governance as well, right, will be massively involved, massively inspired by Polkadot. And the slashing is also going to be inspired by Polkadot. But so we have to be differentiating between different types of slashing. So first things first. So what you're looking at right now, again, all that information in due time, not next week, not in a month, probably sometime next year, next calendar year, when we get to it. Again, apologize for this, but we need to make sure that everything is tested before we kind of sit down to write out the proper documentation. Otherwise, it will be constant back and forth, constant changing of everything, and it's just not the most efficient spend of the time, given the very lean nature of the team. So what you're looking at is the slashing. Now, this slashing is who is subject to the slashing? Subject to the slashing is any validator inside of Ghost Chain for Ghost specific transactions. So let's think about this. So Polkadot definitely has some this whole bridging within the ecosystem. It has power chains, power threads, and stuff like that. And then there's a core chain where the validators are essentially validating that chain, and they're also validating the power chains and power threads. And the idea of Polkadot is, hey, like if you are as a business, would like to start your own blockchain, how about you don't build it from scratch? How about you just come to Polkadot, launch a power chain or power thread, and then you'll have supposedly the community around you. You have a community of validators around you to make sure your operation is decentralized, etc. That's the proposition. That's the proposition. But all that power chain, power thread bridging is not anything that Ghost is doing. It's very different. Why? Because in case of Polkadot, if I am interacting between one power chain one and say the core chain, it's the same set of validators who are validating that power chain and also the core chain. In case of Ghost, that's not the same. Ghost validators only validate Ghost chain, while Ethereum validators, for example, validate Ethereum blockchain. So therefore, we have two different sets of validators, completely independent. They may be overlapping to some extent with like 0.01% overlap maybe, but overall, like they are very, very different, like, statistically different. And that's why we cannot just be okay with that slashing mechanics that I'm presenting right now on the screen. So what is the slashing mechanics again? How much in? This slashing mechanics is for Ghost specific transaction inside of Ghost. So for example, Scorpion sends Ghost, Casper in this case, to Mr. IDK. Good. So that will be like, these transactions will be subject to slashing based on this formula. So what does this formula say is very simple. It takes nodes that are offline, divided by the total nodes, multiply this by 3, raised to the second power, and it takes the minimum between this or 1, and then multiplies by 100%. And that's going to be the slashing percentage stake. So what this formula is really trying to tell you is the more validators who are offline, the higher the percentage of slashing for those nodes that are offline. So you have 100 nodes. Only one node is offline. That one offline node, for the most part, will probably get no slashing whatsoever. What this formula is trying to do, this formula is trying to punish significant chunks of a validator set being offline at the same time, because that has to be characterized as an attack on the blockchain. Right? So let me paraphrase one more time. So for example, let's assume there's 100 nodes and 60 nodes decide to go offline at the same time. Well, those 60 nodes, which is 60%, will be absolutely freaking slashed significantly based on this formula again. We can calculate it. When you calculate this formula out, you will see that within about 10%, and do not hold me up to this number, but within about 10% of nodes offline is still okay. So if less than 10% of nodes are offline, and they could be offline not because they are malicious, they could be offline because, not because they're intentionally malicious. Let's put it this way. They could be offline because electricity doesn't work out, or internet is not working out, or I'm traveling, for example. I just, chilled my node, at the same time, and I'm running like, 20 nodes. I'm not malicious. I'm just like absolutely normal here. So for these reasons, less than 10% of nodes is fine. More than 10% of nodes, those 10% of nodes, therefore 11 or 12% of nodes, will start getting slashed. If it's significant majority, like say 60, 70% of nodes, oh my goodness, the slash will be significant. Not only that, but the consensus mechanism, also from Polkadot and same for Ghost, is 2/3 n plus 1 of validators. So in case of 100 validators, we have 2/3 of 100, which is 66 validators plus 1. So 67 validators have to vote for a transaction, have to approve the transaction for the block to be finalized with deterministic finality of about 2 to 3 blocks, which is about 12 to 18 seconds, right? So therefore, going back to the slashing, if 60% of nodes go offline, we do not have 2/3, right? So out of 100 nodes, we need to have 67 nodes present. But imagine the previous scenario where out of the 100 nodes, 60 nodes go offline. So now you only have 40 nodes, but you require 67 for the consensus to go through. So the chain will be stuck for that specific time. Right? So that for that specific time, the chain is just like not operable, essentially. It's not operable until the next epoch. So we don't have to wait a day. So in our case, era is about 24 hours, epoch is about 4 hours. So we don't have to wait for the entire day for these transactions to go through, but we do have to wait for that epoch, for those 4 hours, right, at most, for essentially for the validator set to recalibrate, to essentially say, okay, cool, the validator set is no longer 100 validators, now just 40 validators. Those 60 validators will be slashed significantly, but the remaining 40 now in the second epoch will represent the 100% of the new validator set. Boom, good to go. And all these transactions that have been sent in the meantime will be held in the mempool. Then after the new epoch starts, all those previous transactions will be processed by a new validator set comprised of only 40 validators. So that is the structure inside of Polkadot. It's very similar inside of Ghost. Scorpion. So chilled nodes is still considered offline. And that's a good question. So that's a great question, and it's a nuance. So if you chill your node and the node is still operable until the end of the era, then for the next era, that chill node that you had is no longer kind of in the validator set, so therefore it's no longer an offline node. So that's a great question, right? But let's assume you need to travel lots of us are procrastinators and we decide to travel last second, or we decide to do things last second. So during the last second, we're like, oh shoot, like we need to turn up the electricity in the entire house. So we don't have enough time to chill the node properly, right? So we just turn it off, to prevent future fire while we're away or whatever. And then in that case, it will be offline. So if you chill it properly, the node is not offline, but we know how it's going to be for lots of us. We're gonna like chill it last second. So if you chill it last second without waiting for the entire until the end of the era, until the end of the day, then yeah, it will be considered offline. So that's a nuance. That's a good question. Mr. Okay. So is a node considered offline if it has not maintained the 6.9 minimum bonding due to slashing? Yes, absolutely. It is considered to be, well, let's put it this way. The node is not considered to be active, period, if it's 6.9 minimum. If it's below 6.9 minimum. So let's assume it has 6 gas per minimum. Let's paraphrase. Let's assume your node has 6 gas per, not minimum, just 6 gas per right now. Okay. Does it have more than 6.9? No, it's not a validator. That's it. It's a binary thing. We're gonna get to this in a second, because I think I know what your next question is going to be. So that's why we have to address this on this call. Because you guys are, first of all, I cannot be more proud of the level of discussion brought by guys like yourselves, by whales like yourselves in the whales chat. This is what this group is needing. Absolutely. The fact that shit is being broken, sometimes you guys break it, sometimes it's bugs on our side. And that's exactly what the testnet exists. And I cannot be more proud of this level of discussion. Like, thank you so much. Really, really appreciate it, guys. Thank you so much for feeling the pain of us giving you buggy code sometimes, right? And also feeling the pain of sometimes you guys breaking things too. That's the part of the that's part of the learning process. So imagine the new guys when the mainnet comes around. Imagine how much information they need to entail, and you guys already have it all figured out. Okay. So far so good. Any questions on the slashing? So this slashing is pretty straightforward. No problem here for the most part. And we did not have issue with this slashing, by the way. So Mr. ADK, your slashing was not part of it. Scorpion, your slashing was not part of it. My slashing, God, I got slashed. Fuck me, I got slashed big time. My bonding was 69 Casper. I lost like almost 10 Casper on the slash. Like, it's crazy. It's absolutely insane. I feel the pain. Thank goodness it's testnet. And on the mainnet, guys, it's going to be the same. Like, right? So yeah, we have to kind of make sure. So if there are no questions, and again, this slashing is not a problem. What is a problem? The problem is this slashing. So this is a new slashing introduced specifically on the side of the bridge. Now, and the reason for that slashing, kind of the reason this slashing exists, and think like you guys felt the pain of it, right? The reason why the slashing exists is because validators on Ghost chain will have to be validating not just Ghost specific transactions, but also all bridge transactions. So that puts a lot of responsibility on validators. So we have council members, but we also have validators. Well, guess what? The slashing applies to all validators, whether they're council members or not, equally, right? There's no differentiation. There will not ever be differentiation. So just to give you an idea, especially if council is listening to us now, as far as splitting the bridging fees between validators and just the council, original designs where, for the most part, it was expected for the council to be representing a significant chunk of the bridge validator set. It was suggested that the bridging fees would go almost entirely to the council. But with the new design, thank goodness, due to new cryptography uncovered early this year and presented to you via BridgeIn and also BridgeOut discussions, which I'll present later today, we are able to make the bridging mechanism a lot more democratized, or democratic, whatever, where all validators will be able to validate and thus benefit from bridging. Okay, benefit is nice, but slashing is also present. So just to put this in perspective, if I'm a validator and the network wants the more validators, the better. If I'm a validator, I need to be a proper validator for the Ghost specific transactions, for Ethereum bridge transactions, for Polygon bridging transactions, for Gnosis bridging transactions, for Ethereum Classic bridging transactions, for BNB bridging transactions. Can I just select which chains I'm going to be validating, which bridges I'm going to be validating? No. As a validator, you validate all the bridges. So therefore, you have to be responsible for all the RPC endpoints. Imagine how much pressure that places on a validator. Hence, the bridging transactions not need to be split between validators and council. Hence, the decision to do that. And now you guys understand why. Because as a validator, lots of you guys, including myself, we did not get slashed on this on these kind of Ghost specific transactions. We got slashed on the bridging transactions. That's where we got fucking slashed. I lost almost 10 Casper. It's crazy. It is what it is. So of course, since there's so much risk to be a validator, the validators must be compensated by bridging fees. Of course, the bridging fees are significant. So far they're running around 200% APY still, maybe even higher. But let's dive into this specific. So this slashing mechanics is novel, right? So it's experimental. Nobody has done this before. Why? Because there are no decentralized bridges out there. So we're literally pioneers. Now, had we not been pioneers, we would be able to uncover at least one protocol where we could, try to be inspired by, right? But there's nothing there. So we have to innovate. So the innovation so far is sufficiently easy. There's it's not anything, like crazy. It's just kind of really easy brick and mortar type of thing, which we could definitely make more sophisticated down the road. But for now, as a testing mechanism here, we have 1 minus deviation times median. So let's assume you have, okay, let me just go through the formula first. 1 minus deviation times median of the class by all the validators, right? That is one boundary. The other boundary is 1 plus deviation times median of all the collapse by all validators, right? And what we're comparing is so the collapse of a validator I. So in this case, let's just use an example, Mr. IDK, right? So Mr. IDK, we're comparing you, right? So we say, okay, cool. So let's assume in that specific example, Van Chin, Scorpion, Mr. IDK, myself, we all validators. So 4 validators we have. Cool. Now, we are just comparing Mr. IDK as validator I. So we're saying, cool. So we all 4 of us, right, have some type of median. Median is the middle number of claps. What's claps? We clap every single time there's a BridgeIn transaction. So we clap for that BridgeIn transaction. So essentially, the clap is the same as recognizing how many BridgeIn transactions each of us saw. So let's assume we all saw the same 4 BridgeIn transactions. Okay, so we saw 4 BridgeIn transactions here, so therefore, so we clapped 4 times each of us. So the median is just 4, right? It's just the middle of all of us. It's just the same 4. Okay, cool. Now the deviation, let's assume is 5%, right? So 1 minus deviation, so 1 minus 5%, so 0.95. So for us not to get slashed, all of us have, well, those of us who do not want to get slashed have to have recognized the following number of transactions: 4 times 0.95. and 4 times 1.05. So if you're going to do the math, 4 times 0.95 is what? 3.80? 4 times 1.05 is 4.20. So if we all recognize transactions between 3.8 and 4.2, we will not be slashed if the deviation is 5%. Deviation is a constant. I think it's 5, 10, whatever, 20%, something like that. We can change that, right? We can make it more dynamic as well. But the idea is now, of course, like 3.8. How can you have 3.8? Number of transactions? You can't. So of course, I'm giving like a very bad example of just 4 transactions. But let's assume we have hundreds or 100, like not hundreds, but 100 BridgeIn transactions, and same 5%. So now with 100 transactions and say 5% deviation on both sides, we for the validator not to be slashed, the validator has to recognize between 95 to 105 BridgeIn transactions to not get slashed. Now, how can a validator not recognize it? Well, the obvious reasons is when the validator is offline, the internet connection is not there, electricity just whatever, for whatever reason, just got turned off. So those are non-intentionally, not malicious, but still kind of detrimental behavior to the network, though not intentional. So those are some of the reasons how that could happen. But of course, that could also be malicious stuff, because while the ghost-specific transactions, there's not much to really happen. So yes, of course, like if you overtake the network, 51% attack, yeah, absolutely, like that's a problem. With BridgeIn transactions, though, how the bridges get hacked? Well, they get hacked by getting access to the majority of signers, right? So in our case, it's a lot easier to battle because our set is significant. Like right now, it's 69 validators or whatever. So to overtake half, or in our case 2/3, is like significant. Like you have to really try to do the job. And once you overtaken it, in order for you to become a validator, you have to go to GhostDAO, push the price up, acquire Casper at a super high price, and then kind of at which point it may not make the economic sense for you to ever even become a hacker, right, for the bridge. So those mechanisms exist, but still, in case of 100 transactions, it's between 95 and 105. Okay. Scorpion is asking, will deviation be changed by on-chain vote by Whales Council? Yes, deviation will be changed, of course. So this whole formula may be changed by the Ghost Cult. Now, Ghost Cult comprised of Whales Council members and ghosties. Those are the votes. Very good question. Same thing with this formula too, by the way. So some of these formulas may be changed through forkless upgrades. Some of these formulas may be changed just by more or less hard forks, but that's still okay. Like yes, that stuff, yes, very flexible. So nothing that we say is brick and mortar from perspective of can never be changed. Lots of these things can be changed. What cannot be changed ever is more on the tokenomic side of like supply, right? Like we don't want to like kind of mint extra stuff or burn extra stuff, whatever. Like the supply of say P ghosts, that stuff is pretty brick and mortar. Same thing with the Genesis, right? That stuff is pretty brick and mortar. Everything else, for the most part, is to some extent flexible. Flexibility is, could be less flexible, more flexible, but still flexible. Okay, so cool story. That's cool. So how the hell did we get slashed? Can you please explain to us how the hell did we get? We got everything. We did everything right. We still got slashed. What happened? Why? So this is why. So of course, when we have 100 transactions, no problem. We have 100 transactions, right? So let's go with that example. So for Mr. Erikinat to get slashed, his node has to recognize between 95 to 105 BridgeIn transactions. If that's the case, he is solid. He's cool. But what happened? So a couple of things. Something was buggy on our side. And they've been fixed. I think we'll be going to be preparing the patch next week to be launched. And something happened due to the network situations, and something happened by the edge case. So first things first, we had a huge cluster of nodes, as you guys know, whose RPC endpoint went off, right? Because it got timed out. So what happened? What happened was, since there was a big chunk representing most likely more than 1/3 of validators. Again, we need 2/3 validators plus 1. So therefore, if 1/3 of validators is presenting issues, it will present issues not just for the bridge, but also for the chain. So same thing with Polkadot. If 2/3 of validators decide to act weirdly, the chain is kind of screwed. Same thing with Solana. If 1/3 decides to do something funky, the chain is screwed. That's why the chain gets screwed all the time. That's why these, in particular, Solana. So, decentralized chains, the set is where the set is sufficiently decentralized. You don't see that many, that many kind of stoppages, right? But when it comes down to say Solana, where 33 validators represent that 1/3 stake, there's a problem. So in our case, one cluster, right? One cluster represented apparently more than 1/3. And you guys know what the cluster is. You can see this on telemetry. What is that cluster? So due to RPC endpoints being timed out, now let's think about what happened. Those, let's just say 33% of nodes, right? For that one cluster. That 33% of nodes from that cluster are now blind. They just don't see transactions anymore. They're just blind, right? Because RPC on Ethereum says, hey, you timed out, bro. That's it. Chill out. Do not look like, stop hitting. Scorpion, trust me, do not apologize. This is what we all need. Thank goodness it happened. We should thank you. Right? Because all of us should thank you, because that's how it's we need to know we need to know our risks. So, and the resolutions around this, right? And we'll talk about resolutions as well. So that 33% of nodes became blind. Now, what's the resolution for those 33 nodes not to be blind? Well, to establish our own RPC endpoints. Why? Because existing RPC endpoints are a complete piece of shit. It's not that the cluster did something wrong. It's the RPC endpoints are shit. Why? Well, because in case of Ethereum, Sepolia testnet in particular, apparently $500 billion is not enough money to fucking launch another 10 servers that cost you $50 a month on DigitalOcean or Cont'd or even AWS or whatever, Google Cloud, right? So they cannot spend the money like this. It's going to be $500 a month, $6,000 a year. Apparently that's not enough. Okay. It's only a $500 billion organization. That's no problem. Where half of all the pre-mine went to investors and the team. Just so you guys know, right? So as you remember, current supply of Ethereum 127 million or something, and 70+ million went on the Genesis to team and also investors. If I was an early investor in Ethereum, I would fucking spend that server myself, right? Because I'm incentivized to make sure that the ecosystem keeps growing, but they don't think like this. Okay, whatever. So we just uncovered, and we knew that, but you guys uncovered that RPC endpoints are complete shit. So what's the resolution? To launch our own RPC endpoints, as we discussed last time. That what that will do to the infrastructure? Well, it will help chains get better infrastructure, because we are now incentivized ourselves to run proper RPC endpoints, because if we do run our own RPC endpoints, we're not going to be timed out, we're not going to get slashed, and we're going to be earning bridging fees. So that's just an economic decision for us. For each of us, for each validator, it's an economic decision. to either use an existing public RPC endpoint or to run our own. We said, okay, do you see an optimal amount of bonding, meaning bond some percentage above minimum? So if, say, you have power outage and you don't catch it for a day till you don't fall below the 6.9, I know there's no financial benefit of bonding more, but this could be a strategy for an insurance policy of sorts. First of all, that's a great question. Secondly, you are 1,000% correct. Thirdly, you are 1,000% correct. Like, that's exactly how you should do it. Yes, minimum 6.9, but of course, to still be in the game and keep earning bridging fees, yes, absolutely better to bond a little bit more, maybe 8 Casper, absolutely, or whatever. Like, each of us will be deciding how much. Yeah, absolutely great concept, great. And that's just, it's not, how to say it. It's not that it does not make sense. It actually makes a lot of sense. Like, it is the common sense type of play. Great question. So going back to this, okay. So 33% are blind. So now the whole bridge is stopped. But that's not it. That's not the only problem. What is the other problem? The other problem is we just don't have that many transactions. That's not the only problem, right? So how many transactions we have? Well, we don't have hundreds of transactions per day. If we had hundreds of transactions per day, no problem. Those nodes would probably just get slashed, those 33% of nodes, and that's it. Everybody else is just, acting as normal. But what happened? What happened is the median of us, right? Like, the number of transactions per day was 1 transaction, maybe 2 transactions per day. BridgeIn, we don't have that many users, right? Yet. So because of that, the median is extremely abrupt. Let me explain. So when we have 100 transactions and deviation is 5%, if you're between 95 to 105, you don't get slashed as a validator. Okay. If you have 1 transaction, what happens? Let's assume 33% of nodes say, and not maybe it was more than 33, it was probably like, closer to 50, right? Or whatever, all together. And again, that's not like the issue of that cluster. Again, like, do not blame the cluster. We need to blame our decentralization kind of, network altogether. Meaning it's more centralized than kind of we want it to be. So around 50% therefore said, hey, I'm blind. I don't see any transactions anymore. I see 0 transactions. Now Mr. IDK and whoever was active, the other 50% said, wait, we do see that 1 transaction. So what happens is 50%, for example, of nodes say we see 0 because we are blind. The other 50% say, well, we see 1 transaction. What's the median? The median is half, right? Because it's between 0 and 1, right? 0 and 1, you add that up, divide by 2, now it's half. So that's the edge case. So what happens when we hit that specific edge case? Well, we all get fucking slashed. All of us get slashed. Why? That's an edge case. It's 1 transaction. The median is 0.5. It's impossible to have a 0.5 of a transaction. Transaction is a whole number. It's an integer by default, right? It cannot be like a decimal. So when it's half, 0.5, and deviation is another 5%, I'll just round the numbers. Essentially, only those who recognized between 0.45 and 0.55 of a transaction did not get slashed. So the first half recognized 0 transactions, they get slashed. The second half recognized 1 transaction, they also got slashed. So everybody got slashed. So what the problem is, like, kind of how could we characterize this problem in particular? Not enough transactions. Is that a problem down the road? Yes. So the patch for that specific thing is being prepared. So how is it being prepared? If we only have like few transactions this era, those 24 hours, the patches, we're going to look at the previous era as well, combine these 2 eras together, and the slashing will be decided after the second era. So again, just let me paraphrase one more time. So if in era 1 we didn't have enough transactions and there was like some huge deviation because again the bridge just was not active that particular time, we look into era 2, and in era 2 we combine era 2 and era 1 transactions, and we figure out the slashing in era 2 for era 1. So the slashing for era 1 decided in era 2. The team said it like eloquently with taxes. That's like a very good example. So let's assume you want to figure out your tax situation for 2025. Okay. So let's assume you owe some taxes, but you don't know yet. Like the kind of your tax authority does not tell you how much you owe yet. So, but they will tell you in 2026 if you owe for 2025. Right. So same thing with this slashing. So in error 2, the slashing will be decided for slashing 1 if slashing 1 is inactive. That's a specific patch. That's an edge case. So again, let's just paraphrase so far. 33% plus of nodes were inactive, significantly impacting the consensus. Inactivity of the bridge was a second problem. I would characterize this as an edge case. So that edge case we did not know about, we did not think about this. So now we know that is being resolved, and we will launch that. We'll integrate that patch, I think, sometime this upcoming week. The third thing is some of you guys got slashed, kept getting slashed more and more and more and more. That was a bug. We had a bug on that, so that is just our fault. We apologize, guys. So let's assume you got slashed, and now your node is supposed to be in the chill mode. You will still get slashed. Sorry for that. That's our fault. That's our we screwed up. So we'll fix that. I think this patch fixes a lot of things. So 3 things happened, not just one. First of all, the cluster of nodes. Secondly, not enough transactions from error to error. And third, the ongoing slashing. Okay? So let me respond to some questions. Scorpion, if I were to build a node RPC for Zipola, is it simple to change my testnet Zipola node to run a node RPC to Ethereum mainnet, or best to not worry about testnet and just focus on mainnet? I would focus on both. I would test both. Because Zipola, that's a great question. Zipola is very close to Ethereum mainnet. I would just really, really, really focus on both. Just for an easier migration, not to have any surprises down the road. The idea for the testnet, so as I described before, like maybe a couple months ago, what's the difference between Ghost and many other projects? Most projects. Okay, I mean, I don't want to say that our team is GigaChat team. It's not humble to say that, but normally, what's the difference between GigaChat teams and soy devs? Soy devs, they say we have a testnet. That's 10% of functionality on the testnet. Well, the mainnet has 100% of functionality, and not even. So they have a testnet which completely has nothing, 10% of functionality. Then they launch mainnet with 10% of functionality and slowly upgrade the mainnet. That's soy shit. So therefore, kind of the functionality of testnet versus mainnet is significant gap. So your testnet means nothing compared to mainnet. So why would you launch testnet? Well, because VC investors want milestones and KPIs. So you launch a shitty version of the testnet with 10% of functionality because they want it. Because you have checkbox, yes, good. But in reality, testnet and mainnet completely disconnected. So when users come to mainnet, the functionality of mainnet completely different from testnet. Nothing can be done. They have to relearn. There are lots of bugs, lots of hacks, blah, 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 blah. What GigaChats do is the testnet and mainnet are 98% closed. The reason for the 2% whatever discretion deviation is due to, on Zipola RPC endpoints are worse than on mainnet, for example. Or on Zipola you have DEX like V2, and on mainnet you have DEX V3. Or on mainnet you have DAI, on Zipola you don't have DAI. There are some physical differences between testnet and mainnet environments just because the mainnet infrastructure is richer to some extent compared to testnet, or vice versa, right? So that 2% or whatever 5% discrepancy is due just to things that are completely beyond your control. But the idea is for the GigaChat team says testnet, you fix it, you run it, and then you just change one command, the endpoint. Instead of the Zipola endpoint, you use the Ethereum mainnet endpoint, and you're good to go. So therefore, prepare for Zipola as if you have been preparing for the mainnet. That's a great question for all of us to consider. Scorpion, on this patch, could you have a minimum number of transactions that may require adding 2, 3, 4 errors to achieve the min? Well, yeah. So we're not going to be adding 2, 3, 4 errors. We're just going to be looking back, and that is resolving everything. So I'm going to present the Git post specifically about that issue. And the Scorpion says, good to know about the bug. Yeah. So we screwed up, guys. Sorry. Now again, the reason why we screwed up is for this slashing, tough to screw up because we just take it from Polkadot, right? So we kind of read the documentation, understand how it works, recode it from scratch, boom. For this one, this is experimental, and of course, some edge cases and certain scenarios we just do not know. That's why there's a testnet for you guys to help us break things, and that's how we learn. Okay? So could we have predicted those issues before? Some of them, yes. Like that's why we do tests. Like a lot of issues, a lot of scenarios have been already forecasted, but you will not be able to forecast everything, right? So therefore, the more we test it, the more we break it, the better. So you guys who are thinking that, oh, breaking is bad, no, break this fucking thing, because the more you break it, the better. Then we'll have like a more kind of more hack proof or bug proof code base on mainnet. Okay, so what are the next steps? Oh, again, we are swamped with everything. So we forgot to do like this, this kind of like the roadmap. So here's the roadmap. So first things first. Oh, and another thing. And sorry, the fourth issue was the bridging between eras itself. So that was like yet a fourth issue that is also like in process, right? So because we communicated to you guys only that one issue, and then the second issue with cluster of like 33%, but in reality there are not two issues but four issues, right? So bridging between errors, that's another issue that also have to be resolved through self-applause. So we're working on that. It's close to resolution as well. Not going to be presenting today. It's very close to the resolution as well. So almost all of these four bugs are going to be solved. So yeah, so the first thing is figure this out, figure the bridging between errors and this whole kind of bug situation and fix that. This like the low quantity of transactions per error, fix that. Non-chilling slashing, fix that. That's what you guys like. That's the continuous slashing. So fix those three issues, right? Now, can we fix the issue with the cluster of 33% being blind through RPC? No, that's each validator has to be figuring this out by themselves. So that's not a protocol issue. That's a cluster or node specific issue. So you guys have to figure it out themselves. So those three have to be fixed by us. Yes, it's RPCs, you guys. Centralization. So is it a bug? Is it a feature? Well, clearly the more decentralized, the better. So what's the lesson for us? Well, if there's a cluster comprised of 33, 50% of nodes, what should we do? We should create more of such clusters. Why should we say no to that one cluster? So one cluster, of course, can get fucked significantly by being slashed. If, for whatever reason, electricity turns off, boom, all 50 nodes now, all 100 nodes in that specific cluster, now subject to slashing. Pretty bad game. Not cool. So maybe decentralize those kind of clusters on your end. But again, that's an independent decision by each validator. However, all other validators need to figure out, oh, shoot, like, if that one cluster with like 50 nodes goes down, oh shit, like I have to have my own cluster. Not only that, but other users on the chain also have to have other clusters, right? So just to put this in perspective, so remember kind of the formula, for like even for this one, right? Like 10%, like if fewer than 10% of nodes go down, no slashing, cool. So if this one cluster has 50, nodes, then all the other clusters have to have 450 nodes together. So that those 50 nodes represent less than 10%. Otherwise, everybody gets slashed. Those inactive users get slashed, right? So that's something to think about, and also RPCs. So RPCs are shit. That's the nature of Web3. Is it good? Is it bad? It is what it is. It's a reality. It's like Matrix. Like, I don't like the fact that I have to live in Xeon and it's like shit and machines are controlling my world. But that's a reality. That's a Web3 reality. Infrastructure is garbage. So we either say, oh shit, and just, and go use Solana, or we take a proactive approach and say, okay, how about we become the change? How about we enrich the RPC endpoint infrastructure ourselves? How? Running our own RPC endpoints. That's how we help change. That's how we help the infrastructure. That's how we literally help the infrastructure. What you could do is this. If you think lots of validators on Ghost will be running their own RPCs, what you should do? You should buy some ETH. Not a financial advice, right? Because you are the kind of the Ghost ecosystem is helping the Ethereum ecosystem. In fact, not a financial advice. Maybe it makes sense to buy all of these tokens that are being bridged, because those RPC infrastructures will be enhanced by the validators themselves. I mean, again, not a financial advice, but just something to think about, right? If you help build something, like the idea is not to buy a stock that you have zero fucking control over because AI is amazing hype. The idea is to buy a stock where you have some control, or business where you have control, right? That's kind of the idea for kind of those most successful entrepreneurs. So maybe that's this, again, not a financial advice. All right, so what are the next steps? The next steps are this: fix BridgeIn with all these issues that have been discussed. Some of those issues, except for from era to era, some of those issues will be fixed again this week. Second thing, goes down launch on ETC. So there's one little thing that has to be resolved. I really wanted to demonstrate to you the formulas behind it, additional formulas. There's one or two remaining formulas that I described last Saturday. One of them somewhat solved. The other one is almost solved. Like I would say 90%. I just need to confirm. And I think we're good to go once those formulas are all crystal clear. Again, they did not change. We just had to understand that they're correct. So once that's crystal clear that they're correct, we're going to launch hopefully this upcoming week with marketing launch in 2 weeks. So next week, technical launch. And then 2 weeks from now is marketing launch when we announce it to you guys and stuff and integrate it into user interface and stuff. Okay. Third, break BridgeOut. So the BridgeOut is not ready, but the BridgeOut mockup is ready for anybody to break. So if you guys have any professors, any cryptographers, any math people, any academia representatives, please ask them to help us break this shit. So the idea is this: if nobody can break the BridgeOut, guys, we figured it out. Congratulations to all of us, and thank you so much, everybody, for your support. Everybody, that's amazing. That's a next pillar of cryptography designed internally. Like nobody has those solutions in the world but Ghost, which is crazy. But if somebody's able to break it, so theoretically you're not able to break it. Again, theoretically, but maybe there is a way. So if there's a way, we need to know, right? Because if there's a way, then it's subject to hacks. All right. So after that, so while you guys breaking it, while we're all breaking it, ideally bring professors, some PhD students, master students, like math, physics, like anything quantitative, cryptography itself, obviously, right? Anything IT, anything computer science, bring them here, just to help break it. So then we have to launch goes down on another chain. We'll have to make a proposal vote as well. So what that change is going to be. So last time, remember, it was between Gnosis, Pulse, and I forgot. Well, Classic, which won, and maybe Linear. I forgot the fourth one. Whatever, or maybe three. Maybe there were 3 chains. And then we have to do multi-chain user interfaces specifically to help enable arbitrage opportunities. So again, fix BridgeIn, launch ETC, while we all trying to break BridgeOut, launch goes down on another blockchain, present multi-chain UIs so you guys see the arbitrage between ETC and chain XYZ, and then we launch BridgeOut for you guys to start fucking making money on arbitrage. Oh yeah. So those are the next steps. Now, let me share quickly what I was referring to. So no Vita monitoring, unfortunately, guys. Sorry. I think these conversations, these topics today were more relevant. All right. So, okay. Okay. So first things first, there's so this full collab description has been published by Stinky, and then there's an issue by Stretch as well on top of that. So that issue 58, check this out on GitHub. That's regarding those bugs on the BridgeIn. Okay, so that stuff you can share if you want, but this is not to be like, this is more like just to familiarize yourself with what's happening, what happened, and how we are going to resolve it. So described, nicely written. This one is to be shared. So this is the Exodus. That's the BridgeOut. This you could share with professors, with academia, try to break it yourself. So you have the formulas that we are using, the references, everything. So it is a task. So if you have any ideas how to break it, please write to us, support@ghoststate.io, or reach out to us as well. So this is definitely to be shared with academia. Could that be shared on Reddit, Quora, etc.? Sure. Just go all out and try to help us break Exodus. Now, if it cannot be broken, congratulations. We have BridgeOut, at least version 1 or version 0. On this positive note, thanks so much. See you guys next week.